Afternoon, everybody, and welcome to the AgriFutures Chicken Meat Program webinar series. Firstly, AgriFutures Australia acknowledges the First Nations people of Australia as the traditional custodians of the lands and waters on which we live, learn, and work. We pay our respects to past, present, and future elders of these nations and any First Nations people who are joining us on this webinar today. In particular, I'd like to acknowledge the Ngunnawal people of Australia, the traditional custodians on the lands and waters where I am hosting this webinar from today, as well as the lands of the traditional custodians from which our presenter for today is based. Now, to those of you who are new here, welcome, and to those returning to the webinar series, welcome back. I'll just run through a little bit of housekeeping before we get underway. We will be recording today's session, and that recording has started, and making that available through online channels. Now, to those who have joined before, normally you do see my video on. Well, unfortunately, we've got a bit of a technical issue between my audio and visual. So today I'll be coming to you almost radio style. So hopefully it's still just as engaging. As I run through these housekeeping items, there will be an introductory poll that pops up on your screen with some questions to gauge who's in a virtual room with us, and we'd be grateful for your responses. Now, as this is a webinar, your video and audio functionality are not enabled, and all that means is that you can best utilize the Zoom screen real estate to view the shared presentation for today, and it also means we can minimize that background noise and distractions to our presenter. We will have time for questions and answers at the conclusion of the webinar content, but in the meantime, there is the dedicated Q&A chat function for you all to ask any questions you may have along the way during today's webinar. So a quick introduction to myself. My name is Sarika Pandya. I am the research manager, part of the broader AgriFutures levied and emerging industries team, and specifically I look after the chicken meat research development and extension program. So one of our key research priority areas, as represented within the strategic plan for the chicken meat program, focuses on improving environmental sustainability outcomes. And what this means is that the program invests in research and projects via industry levies within this area to improve the industry's knowledge on the most significant components of its environmental impacts. And during these webinar series, we host expert presenters to provide you with the latest information on topics that are relevant to industry and these research priority areas. And today's webinar is all about litter management. So as we enter into the cooler months of the year, adjusting the in-shed practices to maintain optimal living conditions that subsequently helps to maintain the health and productivity of chickens requires active management. Now, our webinar today complements a previous program webinar on litter management, which looked at management practices during the warmer months of the year. However, today we'll focus on litter management and tips that are pertinent to the cooler months of the year. So I hope you enjoy today's content. So what I'll do is I'll be introducing our speaker today. Mark, I'll invite you to start sharing your slides. In the meantime, so Mark Dunlop is the Principal Environmental Researcher from the Queensland Department of Primary Industries, and he's worked at Queensland DPI for over 20 years and has led the RD&E in the areas of litter management, litter amendments, energy efficiency, animal welfare, odour and environmental impacts. Mark is currently a program leader of the AgriFutures Chicken Meat Nutrition, Gut Health and Environment Consortium, and has completed several projects within the AgriFutures Chicken Meat program separate to the consortium, and that's what's going to be featured in today's content. So without further ado, over to you, Mark.
So much for that introduction, Sarika. You've already sort of knocked off a few of my first slides, so thank you very much. Welcome, everyone. It's great to be talking with you today. I will make a start. So as Sarika introduced, today I'll be talking about litter management with a bit of a focus on what to do in the cooler months. And firstly, I'd just like to acknowledge AgriFutures and thank them for the opportunity to present this webinar today, and also for the support that they've given us with funding over the years. And I'd also like to thank my organisation, the Department of Primary Industries in Queensland. So we've actually had a name change. We're back to the Department of Primary Industries, for those who haven't already heard. And as always, I'd really like to thank the growers and integrators who have contributed to the research that I do and to the information that I'm bringing you today. It's because of the things that growers share with me that I learn so much, and then I'm able to share them in these webinars. As Sarika said, I'm currently involved in the Chicken Meat Consortium. Sarika did a really good introduction for that. So I'd just like to acknowledge my collaborators from the University of Queensland and all the other universities, and our industry partners as well, for their support with this research going forward. So heading into winter is a good time to be doing some checks with litter or within the shed. The first one, this is just a bit of a summary of what I'm going to cover. So let's look at some ventilation issues, getting the house or your shed tight, and making sure that drinker flows aren't excessive. And it's also a good time to talk about some of the management practices relating to how to control and how to understand relative humidity, which can affect litter drying, increasing air movement, and also ventilating after tilling. And both of these things are really important for trying to dry litter out, manage litter moisture. So this is my starting slide in most of my webinars. Trying to keep litter dry and friable requires management of everything that goes on in the production, from the drinkers, setting up the shed, ventilation, litter management, litter and tilling. It involves the feed, heat and preheating of the sheds is always very important. And of course, the chickens play their role in managing the litter as well. The chickens are the main source of the moisture going into the litter. At the peak of the batch, they're putting nearly 2 litres of water per square metre onto the floor every day. But there can be quite a lot of water going onto the floor even at the end of brooding when they're quite small still. It can be a bit of a surprise to know that there's sort of 1 to 1.2 litres of water going onto every square metre of the floor every day at the end of brooding. I guess, sorry, I should have said that's if you're half house brooding. Once you let the birds out into the rest of the house, that amount of water per square metre reduces because you're allowing them to spread it over a greater area in the shed. But the important thing to realise here is that you've got to get rid of that water every single day from the shed, and that's what the rest of this webinar is going to be about. As well as the chickens adding water to the litter through their droppings, we all know that you can get extra water going onto the floor under the drinkers. It's usually the starting point for moist litter in the shed. One way that this can be reduced is by ensuring that you don't have excessive amounts of water flow from the drinker nipples. And the way to do this is to measure the drinker flow rates. So we've got a device, and you can get these from your integrators, perhaps, or from the, you can usually pick them up from the breed suppliers as well, or you can just use a normal, just a small measuring cylinder. But the idea is to collect water from the drinker nipple for a certain amount of time, say 20 or 30 seconds, do some sums to work out the flow rate of water per minute, and then compare it to how much the chickens need. There's some new or updated recommended flow rates that have come out from Aviagen just this year in their 2025 broiler management handbook. The upper end of the flow rates towards the end of the batch are still the same, but they've started to recommend lower amounts in the earlier week or two of the batch. So if you're not aware of those and you're interested, you can download that manual from the web. I've taken these values and I made up a little sticker that I can put on the flow meter that we use, just to help remind us how much water there should be depending on the bird's age. But measuring the flow rate's really just the start. What's more important is to ensure that you're still getting the chicken growth rates that you expect and that the litter conditions under the drinkers are what you're after. Each drinker nipple type can respond differently between using it with a flow meter and when the chickens are engaging with it. So you can't just sort of go by what the flow meter says and say that's it, that's what the book says, so that's what we're going to use. You still need to monitor that you're getting the right growth rates that you expect and that the litter conditions under the drinkers are what you're expecting as well. You'll still nearly always get a bit of extra moisture under the drinkers, but what you don't want to have is a lot of water in the litter under the drinkers. That's usually a sign that the drinker flow rates are too high or that the drinker height's not set right. It can be a sign if you're getting water under the drinkers that the drinker system could be due for a clean. Or perhaps the drinker nipples or the drinker system are actually worn and may need to be replaced. But measuring the flow rates is a good way to start and be able to compare with what you're expecting. So onto drying litter. There are 4 requirements that we need to do to remove moisture from the litter. The first one is to have low relative humidity in the shed. The second one is heat in both the litter and in the air in the shed. We need to bring moisture to the litter surface so that it can be removed, and there needs to be air movement, and the air movement's required to actually remove that moisture from the litter. And then once you remove the moisture from the litter, it will increase the relative humidity in the shed. And so then the process starts again where you've got to then take steps to make sure that the relative humidity is staying low, and then you work through the rest of the system again. So these 4 things are really critical when it comes to drying litter out. So starting with the focus on humidity, we often hear that there's more humidity during winter, but if we look at the absolute humidity of the air in the air around the sheds, there's actually less water per square meter or per cubic meter of air during winter than there is in summer. So this is called the absolute humidity, not the relative humidity. It's the absolute humidity. So it's the amount of water that's in the air. And it doesn't matter whether you're down in Victoria on the Mornington Peninsula. We can see that in winter, the absolute humidity is lower than it is in summer. It's the same if you're in South Australia, if you're in Perth, if you're in Southeast Queensland, or in Northern Queensland, tropical Northern Queensland. Doesn't matter where you are, the air in winter tends to be drier and contain less water per cubic meter. So why can it be more difficult to keep litter dry and manage litter moisture during the winter? And the thing that we have to understand here is relative humidity. So relative humidity is the amount of water that's held in the air relative to the maximum amount that that air can hold at its current temperature. And increasing the temperature of the air will allow it to hold more water. That's the really critical sort of take-home message. So if we can increase air temperature, it can hold more water, and then its relative humidity reduces even though it contains the same amount of water. There's a bit of a rule of thumb here that increasing the air temperature by 10 degrees Celsius reduces the relative humidity by half. So if the air is about 20 degrees and you increase it to 30, then you will halve what the relative humidity of that air is. And if you have lower relative humidity, it's more able to take water out of the litter when you're ventilating. If you'd like to understand more about relative humidity and how it interacts with litter, there's a short animation that you can watch on the Litterpedia website. I'll have this link again at the end of the webinar with the QR code as well to take you right to that page. So relative humidity. So now we're going to talk about relative humidity within the shed. So if the relative humidity in your shed is greater than about 70%, you will be getting wetter litter, and you'll have wetter litter. You'll get more caking. There'll be more chance of having ammonia, and you'll need to be doing more tilling and probably having to do more heating and ventilation in the shed. So all of this stuff equates to more work and more cost. The aim is to try and keep the relative humidity below 60% in the shed. So if the relative humidity is consistently higher than 60, then it's probably a sign that the litter is damp and that more ventilation is needed. So how do we measure relative humidity? I know many sheds these days will have sensors installed, which is fantastic. So the data gets recorded into the shed computer, and you can go back and look at what's happened with the humidity over the course of the last day or more, depending on how your system's set up. But not everyone has humidity sensors installed in the shed, so there's other ways that you can measure it. One is with a handheld device. So something like this Kestrel wind speed meter that can measure airspeed, temperature, and relative humidity. Not all of their models will do it, so you have to check that if you're wanting to measure relative humidity, that you buy the right one. Another thing you can do is buy a little data logger that's available now that can measure temperature and relative humidity. These record the data within that logger, and then you can upload it into your phone with Bluetooth. So as you're walking down your shed, you can actually connect to the logger and look at the data that's on the logger. And they're really useful because you can look at what the humidity is doing when you're not in the shed, which can be really important. But placement of sensors is everything. There's no point having humidity sensors near the inlets to your shed, because all they're going to be doing is measuring the air as it comes into the shed. What you're trying to do with these sensors is try and get a picture of what's happening after the air is mixed in the shed and as it's leaving the shed. So putting the humidity sensor somewhere near your exhaust fans is a good idea. And if you can, try and measure both the inside and the outside of the shed at the same time. The reason for that is that the humidity will fluctuate during the day and can be higher if you've got, say, wet weather, if it's raining or if it's humid or foggy. But even just in normal good weather, the relative humidity will be higher at night because the air temperature drops outside. And you need to be aware that as the relative humidity goes up outside, it's going to affect what goes on inside the shed. So the risk with using a handheld meter is if you walk into the shed early in the morning and you look at it and you go, wow, the relative humidity is really high, it could just be a sign that the relative humidity outside is higher. So you don't want to be changing your ventilation without knowing the full picture. So if you can, try and measure your relative humidity outside as well as inside the shed. And where I said put it near exhaust fans, one advantage with these little data loggers is that you can move them quite easily. So when you're brooding, for instance, you might put it on one of your sidewall fans, your duty fans, but then later in the batch, when the birds are bigger and you're using your tunnel ventilation fans a lot more, you can move the logger up towards the tunnel ventilation fans. So the big question, how can you reduce relative humidity? The first thing is adding heat. Unfortunately, heat is expensive, but it's one of the things that can reduce relative humidity. So we go back to the rule that I said before, that increasing the air temperature by 10 degrees can reduce the relative humidity by half. So how do we get heat into the shed? Well, the birds will add heat once they're big enough. When they're little, they're sort of not big enough to add a meaningful amount of heat. And so this is why you've got the heaters in the shed. But one really important thing is to try and get heat stored in the shed. So this is where we get into preheating the shed and the warming of the floor and the litter before the birds even go in. So there are recommendations to preheat the floor. So that's the hard floor of the shed, whether it be concrete or dirt. to about 30 degrees Celsius for at least 24 hours before you place the birds. And the reason for this isn't just to make the litter warm for the comfort of the birds, but actually to store some heat in the concrete or in the dirt underneath the litter. Adding heat to the floor will help to reduce the risk of condensation happening within the litter once the birds go in, and will also help to be evaporating water from the litter. Water for it to come out of the litter, it needs to turn from a liquid in the litter into a vapor. And for that to happen, the warmer it is, the easier it converts into a vapor. So by having the litter warm, it will actually help to evaporate more water and help you dry the floor out. So we're still aiming for a relative humidity below 60%. Once the moisture comes out of the floor, and the birds are also breathing out moisture at the same time because that's how they regulate their heat, that water needs to be removed. And so it's really important to ensure that there's enough ventilation. If the humidity in your shed is consistently going above 60%, then the chances are you need to increase your ventilation. But going between either side mode ventilation or tunnel ventilation, side mode ventilation tends to be better for drying the litter because you're going to be utilizing the heat that is within the shed. Tunnel ventilation, where you're just moving air through the shed with air speed, it's in one way it's good because you can get air moving over the floor, which helps to remove water. But you're not utilizing the heat that's within the shed. So growers have said to me that they find that using side vent mode as much as possible helps them with their litter moisture. During winter, evaporative cooling shouldn't be as necessary as it is in summer. So if you can avoid it, try not to use evaporative cooling unless you really need to. And at the very least, minimize the use or don't use evaporative cooling when temperatures are below, say, 29.5 degrees, or if the relative humidity outside is high. And that means that includes at night. So there's no point using evaporative cooling at night because it really doesn't create much of a temperature drop anyway. And as I said just before, if the relative humidity in your shed is consistently above 60%, or you see it trending upwards, and this is the advantage of having one of those little relative humidity loggers, is that you can look back at the trends in relative humidity over the last couple of days or week. If you see it going upwards, then that probably means that your floor is getting wetter and you really need to be looking to increase your ventilation. So ensuring that you've got enough airflow going through your fans, this is one of the ventilation, this is one of the checks that you can do. So I introduced this one during the summer ventilation webinar back in October. But for the winter perspective, it's about ensuring that you're ventilating enough moisture out. So using one of these tachometers, you can look at the fan speed, the rotational speed of the fans, and you can make sure that they're actually turning as fast as they're supposed to be. If they're not, well, then they're not moving as enough air. So many of the computers in the shed will rely on knowing or expecting what the airflow is through each fan as it turns more fans on. If the fans aren't working the way they should, well, then the computer's never going to have the right amount of airflow. So checking the airflow rate with one of these tachometers is a really good way to do it. It's a relatively quick test. It only takes a few seconds per fan, and it can give you a good idea to identify fans that aren't working the way they're supposed to. So with belt-driven fans, these things can help you pick up whether you've got loose or slipping belts. But even with variable speed fans that don't have drive belts, it's good to check them occasionally because there can be technical issues with the variable speed drive that's in the motor, or with the bit of electronics that sends the signal to the fans to tell them how fast to run. So if you can just check that speed, well, then you know then that you're getting the right amount of airflow rate that you need. So there's one thing about removing the moisture from the shed, but we need to get the right air movement going within the shed. And this comes back to the relative humidity that I was talking about earlier on. So the relative humidity outside the shed can be quite high, but it doesn't matter because as the air comes into your shed, it warms up, and as it warms up, the relative humidity will reduce. And so the idea is that by getting the right air movement in the shed, you'll actually have low relative humidity of that air before it reaches the floor. And if the relative humidity is low, well, then it's able to take the moisture out of the litter so it can be removed from the shed. But what I want to think about now is what happens when the fans aren't moving enough air, if the air's not well mixed because the vents may not be adjusted properly, or if there's not enough static pressure in the shed to create the amount of airflow that you need and the air velocity to get this mixing happening. So if it doesn't happen, what can happen in the shed is that the air doesn't actually make its way down to the floor, and you don't mix all that heat. You're not utilizing the heat that's stored in the shed. So the air coming into the shed will be the same. So we'll say it's got high relative humidity. It'll mix with the heat, but then because it doesn't make all the way down to the floor, it just circulates back up to the roof. And so if the hot air is sitting on the roof, where does the cold air settle? It sits on the floor. And because it's sitting on the floor and it's cold, it might contain the same amount of moisture that I had before, but because the temperature's lower, it's going to have higher relative humidity. And so what we've got is we're going to have high relative humidity air sitting on the floor, and then that's going to contribute to condensation within the litter, and will also stop moisture from coming out of the litter. So it's really important to have a tight shed, because having a tight shed improves the control of the air that's coming in through the side vents. It helps to keep more heat in the shed because you're not going to have it escaping out through little leaks and cracks. And as I just showed in the previous slide, it reduces cold air from settling on the floor, which will reduce water condensation. Having a tight shed also allows you to get enough static pressure in the shed, and having that static pressure increases the air velocity coming through those side vents to allow it to reach to the top of the roof apex to pick up the heat from that air, then the heat that's there before it comes back down to the floor. So it's important to be checking the static pressure in your shed by doing a test. There's several ways to do this. Some of them are just to turn a couple of your ventilation fans on, shut all the shed up, and measure what the static pressure is. But you can take it up a level. The University of Georgia have released an app in their Poultry 411 app, and it's a calculator for poultry house leakage. And the advantage to using this app is that it allows you to put in the size of your shed and the ventilation rate of the fans that you're going to turn on to actually calculate how much leakage there is in the shed. And by understanding this, you can then see how much air is just basically leaking into the shed, as opposed to how much air you're allowing to enter the shed in the controlled way through your side vents. And at low levels of ventilation, the more leaky your shed, the more air that's going to be coming in without being controlled, without mixing with the warm air. It's just going to come into the shed and drop to the floor as cold air. And then that creates a lot of issues with wet litter. And there's more information about this app in the University of Georgia's poultry ventilation website. But the app itself is free to download from either the Apple Play Store or the Google Play Store. The Apple App Store, I should say. So it doesn't matter if you've got an iPhone or an Android phone, you can download the app. And then the old school ways of trying to look for leaks as well. So as you're walking down your shed, if you see light coming in anywhere, it's a gap and it's a leak. They're ones that you can fix. And if you want to use smoke to try and find other leaks in the shed by somebody walking outside with a smoke machine while someone is inside trying to look for the leaks, there's a range of these portable smoke machines that are quite readily available these days. A few years ago, there really weren't any in Australia, whereas now there seems to be a lot more of them. And they just use the little disposable butane cylinders, so they're quite cheap to run and quite convenient. So the next thing I want to talk about is just trying to increase air movement in the shed, and particularly at the floor. So to remove the moisture from the floor, you need to have air movement. If you don't have air movement on the floor, you're not going to be removing moisture from the floor. It doesn't matter what the relative humidity is like. So it's really important to get air movement on the floor. Not all sheds create a lot of air movement in the shed. So if you're in this situation where you find you don't actually have a lot of air movement in the shed and on the floor, then adding circulation fans might be a good option for you. They come range of names. People call them circulation fans, stirring fans, destratification fans. Can be some differences, and it's important to know what you're trying to achieve with it. Setting these fans up the way that they used to be as stirring fans in naturally ventilated sheds is not going to make them effective from an air mixing point of view, where we're trying to remove moisture from the floor. We did a survey a few years ago, and we had about 20 to 25% of the growers who responded to the survey said that they had circulation fans. One of the benefits that they reported was that it reduced their heating costs by 20 to 30%, which is kind of the payback for installing them and running them. The main purpose, not what we're really trying to achieve with these circulation fans, is to bring heat down from the ceiling, prevent cold air from settling on the floor, to improve temperature uniformity throughout the entire house so that you don't have cold pockets in the corners or against the walls. And it will also help the temperature and relative humidity sensors that you've already got installed in your shed to get a better representation of the conditions that are throughout the shed. So they'll actually measure your shed conditions a lot better than if you don't have a lot of air movement. But if you have circulation fans, one thing I'd recommend is that you run them continuously in the early stages of the batch when you don't have a lot of other air movement. Because if you don't, what happens is that the warm air that you mix out of the ceiling will just return straight to it again, and then the cold air will settle back on the floor. To really get the benefit from circulation fans, no matter what style you're using, run them continuously so that you keep the air mixed all of the time. And the other advantage to this is that if you do have areas in your shed where you leak, so if you've got some mini vents that don't quite seal up, or if you've got exposed roof purlins that stop the air from moving and circulating well in the shed, having circulation fans can actually help to overcome some of those issues and just keep air moving in a more uniform way. And there's different styles of circulation fans that can be used. There are ones that just work in the area where they are, so we call them a zone circulation fan. And there's a number of products available that you can buy and install in your shed. And then the University of Georgia has been promoting a whole shed circulation system, which has the added advantage of increased air speed and air movement at the floor, which is specifically targeting drying of the litter. But all of these will help to move that heat down from the ceiling and to get it to the floor, and hopefully to keep the air mixed within the shed. The final piece of the puzzle is bringing moisture to the surface. So as the litter dries and the surface of it dries, that dry surface will actually stop moisture from moving out of the litter. So if you've got litter that has had water sort of soak in from the drinkers all the way through it, you ventilate well, you move the air, the surface dries off, and you think, great, but the moisture underneath is going to be trapped there. So by bringing it to the surface with tilling is the way to do it. You will then be able to remove more of that water. And the more water that you can remove, the less that you've got to deal with later and the less of an issue it's going to cause. So after we stir up the litter, it increases the rate of evaporation. So even within friable litter, for the first few hours after tilling the litter, you're going to allow 4 to 5 times more water to be released from the litter. And throughout the night, for the 24 hours after you till the litter, you should have probably 1.5 to 2.5 times more water released up to 24 hours afterwards. Just a word of caution is that tilling the litter also releases ammonia as well. And so what you need to be careful of is that after tilling, so for the night after tilling, that the ventilation is maintained so that you don't allow ammonia to build up in the shed. So what I would recommend is tilling the litter in the mid to late morning at the latest, so that you can have a fair bit of ventilation in the afternoon. But then you need to just keep in mind that there's going to be more ammonia than normal coming out of the floor, and that you need to keep a high level of ventilation so that you can remove it. One thing that we've seen on one particular occasion was that there was tilling done in a shed, and afterwards, immediately afterwards, the ammonia concentration increased, but with ventilation, after a few hours, it went right down. But then as the evening came on and the air cooled down outside and temperatures dropped and the ventilation cut back, the ammonia concentration in the shed increased again. So you just need to keep this in mind and make sure that your ventilation is maintained throughout at least that first night after tilling. So I'll just wrap up now. So all year round is a great time to be doing these checks, but winter is a great time to be focusing on the flow rates in your drinkers. And if you want to reduce your drinker flow rates, trying it in winter is probably a good time to start it. With your fans, just check that the RPM, so that's the rotational speed of the fans, is what you'd expect. Make sure your belts aren't slipping, and even with variable speed fans, make sure that they're spinning as fast as they're supposed to be. In the shed, do a static pressure test, and then look for things that you might need to adjust with the vents, and look for gaps to seal up. Ensuring that there's enough heat and ventilation, so make sure preheating, that you focus on preheating to get that heat stored in the floor of the shed to help you through brooding and to reduce the chances of condensation in the litter and caking from forming. And make sure that if you do any litter tilling that you ventilate for at least the night afterwards. And increasing air movement is one of the really important things for trying to dry litter. So if your sheds have very little air movement within them, consider circulation fans. And if you want a bit of guidance on that, please feel free to contact me so that we can have a talk about how your sheds are set up. So that's it from me for this webinar. Thank you very much for your time. For more information, please feel free to contact me either by phone or by email. And if you'd like more information on this or any other litter management topics, we have a website set up on the AgriFutures extension page called Litterpedia. The QR code that you can see there will actually take you straight to it, or there's the link there below. That's it from me. I'll hand you back to Sarika.
Fantastic. Thank you. Thank you very much for that, Mark. And to everybody on the webinar, we will be in the email that gets sent following the webinar, we will include the link to Litterpedia, as well as which contains a lot of some of the video resources that Mark mentioned. There's a whole bunch of fact sheets in there, checklists, as well as links to fuller reports or scientific and technical reports as well. So this last period of the webinar is purely dedicated to the Q&A. Any questions that you guys may have. We do have one that has come in into the chat. So Mark, I'll go ahead and ask you that. But for everybody else, if there's any burning questions that you have or anything that you're curious about, feel free to pop it into the Q&A function or the chat. We'll monitor that, and I can get to asking Mark those after this first question. So Mark, the first question is, Is there any value in programming the heating of the shed with the time of the day that broilers eat less to prevent heat-related suppression of appetite? So no, it's not strictly speaking just about litter. There's a link in with sort of nutrition, but wondering if you could make a comment on that.
Thank you for the question. That's probably a little bit out of my league, but I don't think there would be any value in programming the heaters for specific times of the day when the broilers eat less. My understanding is that the broilers sort of go through cycles of eating, where roughly a third of the birds are going to be eating, a third of them will be drinking, and third of them will be resting at any one point in time, and they just sort of take turns. So there's probably not too many times where they're actually eating less, would be my thought. So I don't think so. I think probably maintaining a uniform temperature all the time would be probably more beneficial.
For that response, I think it's that interplay between the shed environment or the bird nutrition and shed environment is really fascinating. And I know we mentioned the consortium project at the start of the webinar, but a lot of the synergies and those interplays will be drawn out drawn out of research from that body of work. We've got another question around controlling humidity during winter. And so the specific question is, if a shed cannot properly control humidity during winter, what strategies can be used to reduce litter moisture? Is it good to till the litter in these sorts of sheds in this circumstance?
Oh, good question. I think I probably need to know a little bit more about how, like the causes of how the humidity isn't being controlled. Tilling will help to reduce more moisture, will help to release more moisture, but you need to have that air movement and the low humidity to be able to take the moisture out as well. So probably focusing on trying to control the relative humidity would be the first point in call. I know the question says that if the shed can't control humidity, then what do you do? But I think probably focusing on that humidity is probably going to be the first step. If you can't control the humidity, I guess the question would be, is the heat in your shed being stored, or is it just being lost because there's insufficient insulation, perhaps? And once again, this is where circulation fans, or using that, or having fans that'll bring that heat back down to the floor as best that you possibly can, might be a valuable thing to try. So I don't know if I've answered your question. Whoever asked the question, if you want to get in touch with me, please do so.
And we've not got any more questions, Mark, but one sort of out of curiosity from me, and it might feel like a silly question, but some of the adjustments or the adjustments that can be made that you've referenced during the webinar, given how big sheds are, how is there quite a bit of a time lag or delay in making the adjustments and getting that internal shed environment to where you'd like it to be?
There would be, but that's where having the shed ventilation controller is trying to keep constant conditions all of the time. So assuming that you don't really want to be cycling through hot and cold and strange conditions in the shed. So allowing the ventilation controller to actually control the environment in the shed should help to reduce or prevent big fluctuations. But if it's a matter of, so if you've had moisture accumulate in the litter and then you do make some changes, it might take a couple of days for that moisture to be able to come out and then to see a reduction in the humidity perhaps coming out of the shed again, because it will take a little while to get that moisture out. You could accelerate that process once again with litter tilling, but that's also got to be worked in with how much you're going to disturb the birds, and what other practices are going on and what the weather's like outside. So there's no one answer.
Yeah.
It's just something to keep working at.
And I think one of your bits of advice from within one of your slides is sort of now, or as you're sort of heading into this cooler period, now is the time to do the checks, make sure things are set up to keep things as consistent as possible leading into the next few months. So with that, we've not had any other questions come through the chat or the Q&A. And we've had a lot of information shared throughout the webinar, as well as your offer for people to contact you directly if they've got any specific queries. So I might wrap up the Q&A portion of the webinar and sort of roll into closing it off. So I would like to, whilst I'm giving these final thanks, so bring your attention to the post-webinar survey that we always have at the end of each webinar in the series. And we greatly appreciate your time in providing feedback so that we can constantly make improvements to the webinars and consider as well industry topics that are of interest to your audience. A quick reminder that we will provide the links to the resources mentioned during this webinar following the webinar, as well as as a link to where the recording will be housed. I would like to extend a big thank you to Mark. You're our sole presenter for today, but for your time and generosity in sharing all of the information, as well as the offer for people to contact you if they've got any further queries. And of course, we'd like to thank everybody that has joined us on this webinar today, and those who've registered and will and take the time to watch the webinar later. So other than that, just a reminder to always please remember to report anything unusual or concerns about potential EADs or emergency animal diseases to the EAD hotline. But with that, I'll wish you all a fantastic rest of your Monday, and we'll see you on the next webinar part of our series. Bye for now.